Good afternoon. I'm Qingwang. I come from Chinese Academy of Forestry. Today I will introduce some preliminary results using the UAV LiDAR and photogrammetry. Forest canopy is very important. Forest canopy cover is a kind of parameters is used widely in ecosystem analysis. So it's normally defined replace the vegetation coverage over the ground. It's usually calculated as ground projection area to the ground area. And normally we can use the field work on UAV to measure the canopy or the canopy cover. In order to get an estimate of the canopy cover, we need to discrete which is for the canopy and which is ground. So use the three different structures can easily to distinguish which is ground or which is open areas. Normally, LiDAR and photogrammetry can be used to get the three-dimensional structure. LiDAR can penetrate the forest canopy, and it's much better than the photogrammetry because photogrammetry is quite difficult to estimate the terrain. So we wanted to combine the LiDAR and photogrammetry to estimate the canopy cover. Each number of processes used point cloud can be classified as ground and vegetation and used to generate DSM, DTM, and used to generate canopy height model and normalized point cloud. This kind of tool can be used to estimate canopy cover. My question is, the UAV is a kind of different. It has very high point density, and also for the canopy can have very high point density. So it's similar to airborne layer scanning it's similar, so we wanted to compare the canopy cover estimated using UAV LiDAR and UAV photogrammetry. So we designed an experiment. The study site is located in the east center of China. The main forest is broadly examined oak and maple and the ridge of shrub and storage. So we established 27 field plots and to carry out the UAV LiDAR flight and UAV camera flight. The UAV LiDAR is used the LiDAR P60. Also, it's combined with the high precision TSS and U. This will use the system. So the camera is mounted on another system. The LiDAR system is the specification. Normally, when you know the range of the LiDAR can be the max measurement range is about 120 meters, but it's for the high reflected object. For forest, it will be less than 80 meters. So the study area is the elevation varied more than 100 meters. So the flight was flight along the slope. So the flight height is changed. It's not a consistent flight height. So the flight height is about the slope about 55 meters. And the flight time is about 2017. the point distance is more than 100, and it is used to generate the DSM. And the point cloud classify the ground and vegetation and building, and you have some tower. It's for watering the forest. And use the ground point to generate the DTM. And the LiDAR DTM we use to generate the LiDAR, the NPC, it's Normalized Point Cloud, and CHM. And so the UAV-based camera was used two cameras. The first one is the high resolution camera, is the Canon ES 5DS, and the second is the microsense red image. It's a multi-standard, and here we only use the high resolution camera. So this camera is 50 million pixels. It's very high resolution. So the flight height is about 300 meters, and the ground resolution is 23 meters. We use the photo scan to generate this one cloud. Here I wanted to mention that we use this software. I want to use will be to choose different options. The important is how to select the point filter method. It has three options. Mild, medium, or aggressive. We use mild. It means that we keep most point and filter out very less. And if you use aggressive, a lot of time will be filled out. That's the point distance is more than 300, and with the point this one to generate DSM. So here we generate the photogrammetry NPC and CHM use LiDAR DTM because photogrammetry DTM is not correct. Here we calculate for the chemical use this formula. It means if the canopy height is higher than a specified threshold, here we use the 2 meters. It means that if the canopy height exceeds 2 meters, it will be regarded as the canopy, and otherwise it will be regarded as the understory to calculate the canopy cover. So we compare the CHM and the NPC forest canopy covers and the LiDAR and photogrammetry exactly. This is the primary result. The highest coincidence. Oh, sorry. The highest correlation between the photogrammetry NPC and the CHM is in the forest CCC. It's indicated that the forest photogrammetry CC and NPC is very similar. It's there are no obvious difference. The LiDAR NPC and the CHM is lesser than photogrammetry. And the photogrammetry system and between LiDAR and photogrammetry system is much worse. Here we can sorry. can see that the photogrammetry CHM is a little smaller than LiDAR CHM-based CC. And later I will discuss why it's phenomenon. And another NPC also is not as good as the CHM. The other two analysis the difference between photogrammetry CC and LiDAR CC. We selected 4 points. First one and second is the small crime areas, and 3 and 4 is for the outstanding crimes. You can zoom it to see the difference. Here you can see there's small gaps between crimes from LiDAR CHM, but this area was filled in photogrammetry CHM. It means that photogrammetry tended to overestimate the small gaps between crimes. If you use when you generate this on the cloud, if you use aggressive filter method, this phenomenon will be more serious than here. Another example is this site is also the small gaps between crimes was filled by the photogrammetry. So if we only consider this situation, the CHM, the photogrammetry CHM-based CC should be higher than LiDAR, but in fact it's inverse. So we found also there's another interesting thing is there. We decided the crime cluster it's a LiDAR CHM, and we also overlapped with the photogrammetry CHM. We can see that some areas was not occurrence in the photogrammetry CHM. I think it's very quite interesting why this will happen. Maybe I think maybe in the mountain areas and the height, the elevation of the tree cross is changed. The software to process the situation, maybe this software. I just guess. I think maybe we should use another software. Here I use the full stack. Maybe I can use the Pix40 or software to test whether this is the common problem or only exists in the full scan. You can see another example is it also is outstanding 2 crimes. It's also this area was not so good. So it's a reason why I think maybe it's a reason why we calculate the canopy cover. The photogrammetry is a little lower than LiDAR. So I think such a phenomenon should be considered when you calculate forest parameters. And some correction may be should be applied to correct such a problem. So also the photogrammetry problems, the concrete effect maybe depends on different forest select. Maybe in this side, the photogrammetry is underestimate for CC, but in other side maybe it's will be overestimate. So we need to test in more areas to see whether it's common or it's special. Second is the LiDAR scan angles is also have an effect on the photocanopy CCD image, especially large scanners will obviously overestimate for the CC. So this will be discussed. And another question is, also I wanted to mention is that I find a very obvious phenomenon or problem in another test that the lost little pulses has obvious serious effect on photocanopy cover. What's mean lost little pulses? It means if the layer, if the LiDAR system transmit laser pulses, but there isn't any backscattered signals from the target. It's because the lower reflectivity of the targets. Normally, the first canopy have lower reflectivity than open ground. So, if the lost pulse is serious, it also can lead to the underestimate for its CC. So maybe it's the scan rule and lost pulse they can composite to affect for the CC. So I calculating the canopy photogrammetry CHM and NPC has similar estimate, similar and a very high correlation between this CHM and NPC. And in total, the CHM for CHM-based CC is have high precision than NPC-based CC. So. A lot of people have contributed to this work, so I want to thank them to organize UAV flight, to process data, and to coordinate. The test data is a military area, so we need to coordinate with the military. There's a lot of coordinated work to thanks they have there. Thanks for this work. Any questions and comments? Thanks.
Do you have questions?
Thank you very much. I didn't understand what you said about underestimating canopy cover because there will be missing pulses on the ground compared to the vegetation. Would you expand on that? I didn't really understand. It was one of the first slide of the conclusion, the last point that you were having.
The last point?
Yeah, 2 slides ago. Not the previous.
This one?
Previous.
One more back.
One more back.
The last one.
The last one. Yes, it's I have published in the Translation of Data Science and System. It's online. It's test data is located in the west of China. It's conifer secondary forest. This phenomenon is, I think it's very representative. I provide a new model to correct this phenomenon, and it increased accuracy, obviously. So I think in some cases, especially when you flight, the normal UAV are able, if the flight height is within the maximum range. I mean, if the LiDAR have 1,000 millimeters range, if you fly at about 900 or 800, this phenomenon should be considered because the slant distance, I mean, with light scatters, this phenomenon will be obviously exist, so that should be corrected when you calculate can be covered.
Which is the journal and the title? The journal and title of publication for the
How to correct it?
Which journal is that?
Which journal?
Which journal?
Oh, journal.
Was published in which journal?
IE, transaction on geoscience and remote sensing.
Okay.
Okay.
Okay, we have to move on. Thank you.
Thank you.
Thanks for him.